Okay, so we have this table. And again, a reminder, I'm actually going to do something. I'll do it with the highlighter here. A table is a collection of coordinates. So each of these is actually a coordinate that I could put on a graph if I wanted to. I'm going to do something off to the side here. And I want you guys to see if you can figure out what I'm doing. Okay, here we go. What did I do?
Where's the 4 at? Oh,
Alan?
you found out like all the numbers that are on the X side. Like.
Yeah, so they're the X's, but I have 1, 2, 3, 4, 5 numbers, but there's 1, 2, 3, 4, 5, 6 X's.
Because there are 2 2s.
So why do I only have 5 numbers when there's 6 originally? Jackson?
You have 2 2s.
Oh, okay. So once I had a 2 in the list, it's already in the list, so I didn't need to write it out again.
Yeah.
So basically what I did was I made a list of all the different X's with the duplicates removed. So once I write 2, I know there's at least 1 2 in there, so I don't need to write it out again. So that's all this is. It's just a list of the X's with the duplicates removed. When I do this, though, this list of numbers gets a special name in math. It's called the domain. So again, all the domain is just the list of X's with the duplicates removed.
Will we do the same thing with the Y?
Okay, well that's not bad, right? So this has kind of a fancy word, but what it is really isn't that complicated. It's just X's without duplicates.
Are we going to do the same thing with the Y?
Okay. Yeah, so if I could do it with the X's, I could do the same thing with the Y's, right?
But why?
We're going to talk about the but why part because it's going to help us talk about what a function is. Okay, did you guys notice too, and you don't have to do this, but it's a nice thing to do. Did you notice when I listed these out that I also put them in order?
Yeah.
It just makes it a little easier to keep track of things. They don't have to be in order, but a lot of people do put them in order. Okay, so I'm going to do the same thing with my Y's. So I've got a 4. I don't know how many 5s I have. A 6. I've got a 7. I have 2 8s. But I'm not going to list it out twice. I'm just going to put it in there once. We're not doing duplicates.
Why don't you list them out twice?
And then I have a 9.
Like, what's the reason?
Well, because this is telling me what all the different inputs can be. So once I have a 2 in the list, I already know that I can have an input of a 2. If I want to use it again, that's fine. I already know that it's a possibility. So this is basically what are the possibilities. So this is the same thing, but with the Y's.
You didn't
Right?
write down 7.
Oh, you're right. Let's squeeze in our 7. There we go. 4, 6, 7, 8, 9. So this is the same thing, but now it's the Y's. List of Y values
And now what are these called?
with duplicates removed. You're right. If the X's get a special name, the Y's are probably going to get a special name too, right? Now, this can get a little bit confusing, but it's something that happens a lot in the English language. This list of X's is called the domain. This list of Y's is called the range. Where this gets confusing is that a lot of you guys have learned about a different type of range in math.
The maximum minus the minimum.
What other type, yeah, what other type of range do you guys know about? Largest minus smallest. So now we have one word for 2 different things. And that happens a lot in English in general. You guys can probably think of other words in the English language where you have one word and that word means 2 totally different things depending upon what you're using it for. That happens with math vocabulary too. So you have to be careful with it because in this context, when we say range, we're not talking about the largest minus smallest range. We're talking about the list of all Y values with no duplicates range. Very different. There's one more thing I want to show you, and then we're going to be ready to talk about what a function is. I'm going to scoot this. So I'm going to take the same information, and right below here, I'm going to do one more thing with this. Let's see if you guys can figure out what I'm doing. Where'd I get those numbers?
the domain.
The domain. Okay. Where'd I get those numbers?
All you're doing is just
The range.
putting them in order.
Okay, now I'm going to do something, and I want you to see if you can watch and figure out what I'm doing. Okay, I'm done.
Why would you like go
What
that
did I
fast?
do? Samantha?
You just weird arrows to the X, Y. To the arrows.
Yeah, so I put arrows. So how did I know where to make the arrows go?
Because you have a table with the matches up
Oh,
above.
the table. Oh, okay. So each of these arrows is one of my coordinates. 2, 6, 2 to 6, 3, 8, 3 to 8, 5, 8, 5 to 8. So I can take my domain and my range, and again, I'm not using the duplicates here. Okay, so I don't need to write out the 2 twice or the 8 twice. I can just double up where my arrows go instead. And if I connect those based on the coordinates, it makes a little diagram like this. This is called a mapping diagram.
So what do we do with this? How does it help?
So a mapping diagram, basically what it does is it uses the domain and range to show the different coordinates that are in the data.
But could you just look at the original and just see the coordinates?
The biggest difference between this and a regular table, so if you're thinking, why don't I just list out the table? The big difference is I'm using the domain and range and not the actual data, so I have my duplicates removed from this compared to the regular table. The reason why we have this is because it's going to help us figure out whether or not things are a function. We're going to talk about what a function is in just a second. And this is going to help make it easier to see whether something is a function or whether something's not a function. It has to do with the relationship in the coordinates.